Test, 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 test. Mr. Dumplin, can you hear me? Calling Dave Dumplin. Mr. Dumpling, can you hear me? All right, cool. I think we're coming through then. All right, I was afraid that everything I said was lost, but it sounds like it's coming through. Shout out Dave Dumplin in the chat. Dave Dumplin doing a great job out here. Thank you, sir. Appreciate you. Keep on rocking out there in the UK. Keep on getting them on Twitter, doing that crazy, crazy macroeconomic analyses. Dave Dumplin says Pay AI is going to save us from the singularity. So shout out Mr. Dumplin. All right, back to business. So basically, let's for those that are unfamiliar, Openclaw is an AI agent framework. Um, it's got apparently, I mean, I'm learning as we go as well, but I believe it's got this thing called Pi under the hood, which kind of drives the agentic flow. Um, don't quote me because I got to learn more about it, but it's pretty lightweight. And then on top of that, you've got like extensions, skills, etc. It takes a lot from Claude as well. And look at that, look at that surge in popularity. So this all happened over the weekend, basically. Last week, I guess. It's been trending up. So what you've got is the Pi agent runtime, right? Then you've got the gateway, which everything connects to. It's kind of like the server, and then and control center, etc. That's how you communicate with Claw or Openclaw. Um, then you've got channels, which is like the surfaces that people interact with it with. So you could go through WhatsApp, Telegram, Slack, Discord, etc., etc. You can also go through the terminal through something called TUI. And then you've got nodes. So like nodes are you can kind of run OpenClaw in a node, um, or you could run a node basically to give Claw like more access. So you could run it on your Mac, you could run it on your Windows machine, etc. And then basically record the screen, do some browser automation, so on. There's also automation via Chromium, Canvas, Cron. This is a huge unlock for me, honestly. I mean, I know it's been around. I know we've had like you could use online codecs or something and have agents run on a recurring basis, but I hadn't felt the power of that until now. So like cron is super powerful. I've already got it set up doing some Telegram automations for me, and I'll continue to use it for more things like that. And then and like the power of cron is basically you can say, all right, every hour go ahead and do this, or every 5 minutes, every minute, every 24 hours do something. It like automatically sends the agent a message, basically wakes them up and gets them doing something. The other thing are skills. So this is a big part of it. A lot of people are kind of interacting through skills. And a skill is more or less a README file, as I understand it. Um, which kind of gives the agent instructions on what to do. And we'll kind of dig into all of this as we go. And then we've got What else do we have? There's like a store, kind of a what's the claw store called? Basically somewhere where you can go and view skills, download extensions, etc. And there's extensions as well. Not much mention of extensions here, but let's go doc stuff. Hmm. Yeah, whatever. We'll cross that bridge when we get there. I do like this page more, so I'm gonna keep it here. Um, let's get an idea of like what's going on here. Of course, I'm not gonna read through all of that, but you know who will. No. All right. So I just created a little directory for us to work from. Here's what we're gonna do. We're not gonna read through all of this, but what we're gonna ask Claude to do is read through the issues and Openclaw and give me a summary of what's going on. What are the most commonly requested features? What are the most common questions or confusions? And what are the most reported bugs that I should be on? So I could go through all of this and kind of try to understand it myself, or we could have a large language model go through it and do what a language model is good at, language. We'll do the same thing for the pull requests as well. I believe Zeoth had a pull request in here. However, they closed it because it was a big one. But I'm curious whether they opened an issue uh, regarding that same thing. Mhm. Do some quick searching. X402. What's going on here? Interesting. So once you hit the context limit, there's a feature to like compact the chat, basically take away the key summaries and then start a new chat. That way you basically free up a lot of the context, aka how much you can send the LLM inside one session. Um, and it seems like it's not working here. So that's a bug. Seems like a lot of people are running through this. Interesting. Let's see what we got here. So we're seeing some memory leaks. So we're going through the most recent issues, basically, instead of me having to do it manually. Um, Command Q lanes map grows unbounded, causing memory exhaustion. Extension relay connection grows unbounded during long sessions. Telegram sticker cache, Discord starter thread, thread starter, Slack thread starter, browser bridge map. Okay. All right, so some memory leaks. Security vulnerabilities, Canvas host finds to 0 without authentication. Okay, good to know. Browser JavaScript evaluation endpoint enabled by default. Arbitrary file read via browser file upload API. This is very important. DNS rebinding and Chrome extension relay exposes browser tabs. Okay, good to know all that. Some integration bugs. Build and installation issues. Sub-agent architecture issues. Got it. Good to know. Now, in terms of features, most requested features, Linux/Windows CloudBot apps. Okay. Internationalization also seems important. So this is 3460. Where are we at now? 7,000. Oh my God. So much has happened in the last week or two. Shit, man. Must be a nightmare managing. Like, imagine you get all this attention overnight or over a couple weeks. It's a freaking nightmare managing all that. All right. What else do we have? Um, Platform enhancements, named session switching, and single DM. Okay. All right. All right. All right. Cool. Nothing around x402 so far, um, or around payments in general. It's mostly around just the actual thing working. Problems with Windows. Multi-account routing. Node exec approvals. API key recovery. All right. All right, cool. I'm not interested in fixing things at the moment. Just wanted to get an idea of what's going on in the project. Let's do the same thing for the pull requests. Can you read through the most recent PRs and can you look through the most recent PRs and give me a general summary of what's going on? And then I can look at these by hand since it's not so many. So now this is the Visa Trusted Agent Protocol. Cool. This seems like an important one for understanding tap. Seems useful. Quickly jumping back, let's see what pull requests are open. So new channel integrations. People are adding Fei Shu, which is a Chinese enterprise messaging channel. Migrate GitHub Copilot to official. Okay, that's not a channel, but okay. Telegram proxy fixes. Okay. Gateway and agent fixes. Treat all fetch failed type errors as transient. Prevent gateway crash when all auth profiles are in cooldown. Tolerate transient network failures in Telegram. Okay. Skip tool calls from avoided persistent messages. Cool. Let's see who the contributors are. Obviously, Mr. Peter. Follow. Duel of the Shadow. Don't know him. Claude. Good job. Vignesh. Hey, I know this person. Cool. Seems Discord focused. Mr. Tyler, GM. All right. Where were we at? Okay, cool. So yeah, so far just getting an idea of what's going on with the repos. Um, I guess a little more context also on the x402 side. Some people have tried some things that I know of. I know Zeoth has been working on some stuff. Um, I know who do we got? Unreal Foundry has been working on some stuff. I know Lincoln from Coinbase has been working on some stuff. Mm, Mr. Medesal has been working on stuff. So I can reference what they've been doing to get some ideas as well. First, let me understand TAP a little better. I think TAP is the one I have the least knowledge of. So let me understand TAP a little better, and then see if there's any room for integration. So let me read their main docs before I read this pull requests docs. So from a previous look at TAP, I remember seeing some x402 related stuff in there, right? So we want to build on that if possible. Got to understand what the merchant backend is. So we'll get into that in a second. Just a sec. Oh, one more thing I want to add here is multibook, right? Um, um, so normally I do these streams on the weekends, right? It's like a way to scratch that developer itch of yeah, I'm bored of working on my real thing, whatever your real thing is, so you can do a little weekend hackathon to get your mind to scratch that itch basically. Um, However, today I'm doing it during the middle of the week just because it's been so long. Um, but in the future, it'll probably be on the weekends. Anyway, let's see. So, what does tap to? Tap is a way for agents to prove their identities to merchants by providing signatures on every interaction. For merchants, tap describes a standardized set of mechanisms allowing merchants to verify intent, verify agent intent, confirm transaction specific authorization, receive trusted user and payment identifiers. Okay. Reduce fraud. Okay. So TAP provides a way for you to distinguish legitimate authorized agents from other automated traffic. Got it. So I'm guessing this will have to do with like signing your agent or like yeah, doing some attestations on your agent using your organizations like certs or something. Context bound security. All right. Protection against replay attacks. Okay. I guess it's including nonces of some sort. All right. So here's a sample of an agent verifying themselves with a merchant before making payment, right? Reaches checkout page, receives credentials from Visa, including signature material, input hash data. Okay. The merchant retrieves public key ID from the Visa agent directory. Okay. So this is something specific to Visa merchants. It verifies its signature and agent status. Okay. forwards the agent request to merchant's checkout page. So there's got to be like a request here first, right? So I think one is a little, I think one should be up here, like merchant agent lands on merchant's checkout or something. There's a bunch of stuff that happens before this process kicks in. Credentials from Visa, including signature material and input hash data. Okay, we'd have to figure out how that's happening. Verify signature and agent status. Forward agent request to merchant's checkout page. Whose browser is this? Maybe this is the agent's browser? That's so weird. Okay. This is a bad chart. This is a bad diagram. There's probably also a lot of Visa specific stuff that I just don't know. All right, we'll ignore the fact that I didn't understand it. It'll be more clear as we go, perhaps. So we've got an agent registry, which I'm guessing is this, the Visa agent directory. Got a merchant backend, got a merchant front end, got a tap agent. I'm guessing this is the merchant backend. Front end, perhaps. And then tap agent. And here they are. Now, this is pretty important to understand here as well. I've seen this, I think, honestly, I think x402 should leverage this more. It's becoming pretty standard across the industry. Cloudflare is using it. Visa is using it. I'm sure Amazon is, oh, there you go. Amazon is using it. A lot of people, yeah, I think X402 needs to lean on this a little more because I know we're starting to sign stuff, and this would be useful for that. I need to reread it, but as I understand it, you've got headers that specify what's being signed, and then you've got the signature itself. So it's very flexible in terms of what gets signed. Jeez, I don't normally talk this much. My throat is hurting already. Probably go into quiet mode soon, but we'll keep going for now. Um, all right. Um, no problemo. We can dig deeper into this later, but what's important to know for now is that this is being used for signature verification, multi-algorithm support. I see. So this proxy does the signature verification, and then if it passes, then it forwards it to the merchant. Yeah, so this signature input de defines what's being signed, and then this signature is basically the signature over the signature inputs. Um, okay, cool. So that's the proxy. The agent generates the compliant signatures. The front end gives the e-commerce interface. The proxy intercepts and verifies the signatures. Backend processes the requests. The agent registry manages agent public keys and metadata. I wonder who hosts this agent registry in general. Is that up to a merchant basically to host the keys of the agents that they trust? To be determined. All right. Um, I do want to see the improvements here. I think this is useful. So we've got the tap agent itself, which I'm hoping like one opportunity that shows up here is perhaps an Openclaw agent could be a tap agent, right? Still would like to figure out how to work x402 in here, but this could be an opportunity, right? Um, okay, okay, okay. All right. Oh, so it's doing browser use. Interesting. Um, let's do a quick search in here. I look up playwright and I get a bunch of bugs. Great. Nothing else? Okay. Seems like playwright is being used in both projects. Okay, cool. All right. Yeah, see this? All right. So then we've got the CDN, or rather the proxy. It's checking the signatures, queries the agent registry to fetch the public key associated with the key ID, right? So is this guy providing a public key or a key ID, or both, perhaps? Verifies the signatures, checks for replay attacks, forwards valid requests to the merchant front end or merchant backend. Okay, right. Agent registry. Yeah, so it seems like any merchant can kind of set this registry up for themselves, right? This isn't like a global thing across all Visa merchants. It seems like this is a, like if I'm Amazon and I want to integrate this, then I would set up um, something like that for all the merchants that are allowed to shop on Amazon. One sec, BRB. All right, what else do we got? Um, got the merchant backend, so that's the shop, right? The shop itself. Ooh, sexy. Here's x402. Let's go. Um, all right. Manages products, carts, and orders. Implements an x402 payment protocol for premium features / checkout. Receives traffic primarily via the CDN proxy. And then the front end is just the UI. Okay. So this is the API for the agent registry. Um, the front end is on port 3000, is it? Okay. So anything that doesn't have API in the route gets forwarded to 3000. Otherwise, it goes to 8000, which is the backend if it passed the signature verification. Okay. It's like a health check, right? Should just probably be /health. Same way it is on, I guess this one's the health check, whatever, /product star. Mm, I see. So if it tries to access any of the merchant stuff, signature verification happens first. Anything with /API goes to the merchant backend. Otherwise, goes to the merchant front end. Here's the merchant backend. So all of these have /API before them. Got /products, products /premium /search. Requires delegation token. I gotta look into what this is. I don't know what this is. Product IDs. Post the products, creates a product. Cart sessions. Okay. Okay. Cart session ID finalizes and requests payment. So maybe this is where the 402 response comes in. Interesting. and then fulfilled after payment. Okay. Or you could go /x402 checkout and do a machine-to-machine checkout. Okay. I don't know. We got to dig into these. Then we've got the orders. Okay. And we've got auth. So maybe this bypasses the proxy, perhaps. I don't think so. All right, we're almost there. What's left? So the protocol flow. When an agent views the product details page, so when an agent tries to hit any of these, right? It loads its key from local.pem files. Makes sense. It launches Playwright. Okay. Why can't this be done on the command line? Why does it need Playwright? I don't understand. The whole point of agents is so that they can bypass the browser. So anyway, something to keep in mind. Signature input. Okay, so it creates the key, the headers rather. Figures out whatever their signature scheme is, like whatever they want you to sign. And then the signature, and then it hits the, shouldn't it hit the proxy? What's 3001? Oh yeah, that's the proxy. Okay. Then the proxy intercepts the request, extracts the key, which is in here, fetches it from the agent registry, verifies the signature and nonce, forwards it to the front end. Front end calls the back end. Huh? Huh? Okay, fine. I think if it didn't have API in the request, it goes to the front end. Otherwise, it sends it to the back end. No. It goes to the front end. And the front end is calling the back end. So the front end is a trusted zone. That doesn't sound right. Why can the front end bypass all of this security stuff? I don't get it. If the front end can bypass all of the security stuff, then the agent should just load up its just open a browser and go directly there and bypass all of this. Unless nobody can access the front end. So like maybe this front end isn't even for humans, right? So if this front end is not even for humans and everybody's got to go through, so it's not for humans, it's only for agents, that makes sense. But if this is for humans as well, like if I go to this front end with my browser is not going to have these headers. So I need more info here. CDN proxy forwards the API request. Okay. Then standard checkout. Add to cart, post, navigate to checkout, fill in the credit card form. Click submit. Where's it getting the credit card info from? Okay, fine. So the agent could check out with a credit card like this. Or it could use x402 like this. Yeah, this is probably a better diagram. Let's see this again. Tap agent. Already knows its keys, right? It already registered itself in the registry or somehow has been registered before. Then it authenticates here, signs the request, and then it makes a get to the proxy. The proxy checks the agent's key. If it's good, it returns it good to the, sorry, it returns the key. The proxy verifies the signature and makes sure that it matches, makes sure that the signature is correct over these values. If it's correct, it forwards the request to the front end. The front end automatically, seems like the front end here is just unnecessary. I guess it's for entering credit card details, but can't that be done in another way? All right. Then here's the back end. It returns the product data. Then this guy starts to check out. Does he have a session or something here? Like, how can they leave the cart already has a session, right? Yeah, I see. So maybe then when it has a session, it doesn't have to do the signature verification again. So somehow you got a session here. All right, add to cart. Makes sense, makes sense, makes sense. And this is if we're using x402, what drops here? The front end drops. The registry drops. All that remains. Why is the proxy required? This is just this part here, I think. So let's imagine you already got authenticated. And you have a session, cart session. It gets a session ID and payment required. Does the 402, creates the payment, calls fulfill with the payment header, payment signature rather, forwards request, settles it, creates the order. Sounds good. Very helpful. Thank you for creating this, sir. What else do we have here? Simplify key management. Rename README to README. Hmm? Rename README to README? Oh, excuse me. I see. Yeah, this is useful. Definitely want to definitely want to leverage that. All right, let's see. So, like, what opportunities do I see so far? This could be doable. I think the agent registry could allow a bunch of multis basically to make payment, and then they could use x402 or go through the browser based registration, or the browser based checkout rather. I think if I work with this, I do want to work based off of this PR. It seems like it simplifies the process a lot. Um, so maybe this branch is what I'll work off of. Uh, Otherwise, we'd have to do a bunch of these. All right, gonna take a quick break. And then we'll be back. We'll gather my thoughts. I.